Hi, I'm Connor. I'll be doing project 3 for fluids. So first we're gonna click on geometry, just make it 2D, and then we're gonna open up a new design model. So we'll wait for that to open. The Z-axis, create a sketch. Go to sketching, make a circle, and then for dimensions, I made mine 1 meter, and then you're going to make a big rectangle for the boundaries. And then the dimensions. Right, so no, I make a 50 meter by 50 meter box around my rectangle, my sphere or cylinder. And then I just use the half to center them. And then that's H5. All right, and so that's pretty much it for this part. We'll go back to modeling, sketch, concept, surfaces from sketch, apply, and then generate. And yep, that looks good now. So now that that's done, we'll go ahead and open up mesh and create a mesh to then do the rest of it. So here we are. I'm going to start by just naming everything. This is not meshing. We can close out design modeler now. All right, here we are. Start out by naming everything. So we'll call this inlet. Outlet. And you press N to, you select it and you press N to shortcut to the name selection. You can just call these sim, and then the 2D cylinder, just the circle, use call wall. And then that should be good. Yeah. All right, cool. So now we'll just start with a regular mesh, generate it. And we'll turn off the mesh defeaturing. Generate that again. And now we'll go ahead and this is in the way. Just move zoom out of the way really quick. Now we'll do deflation. Go there. The boundaries there, and then maximum layers, we'll do 5. that. So now we'll do some sizing. By capture curvature. Element size, we'll do 1e minus 3. Generate. Before that, actually, let's go ahead and do delete this really quick. Go to method, geometry, and we're going to do triangle method. Generate. All right, there we go. And now we'll do sizing. Now we can do edge sizing. And 1e minus 3. I believe. Let me just check on that. Yep. And go ahead and generate. And we keep capture curvature on because we have a circle this time around. So now that's defined. We're going to do another sizing. Use control to select multiple entities. Press apply, and then for this one we'll just do 0. I believe I used 0.2 and generate. Then that is it for the mesh. It looks good, defined, inlet, outlet, and in the where the circle is. So it's looking good. We'll go back to here and update. And I'm actually just gonna save this in case it crashes. I don't have to redo the video. All right, now we'll go once it saves to setup. Full precision, and I run 4 machines at a time just to speed it up. So now we are here in the Fluent itself. That's starting up my closeout meshing. Then I'm also just going to name it here. So this will be for the Reynolds number being less than 1. All right. So once you're here, you'll go to viscous, change that to K epsilon, enhanced wall treatment, pressure gradient effects, and hit OK. And then go to material, fluids, air. For my 0.7, I believe I did 0.7 for less than 1 with ones across the board except for velocity, just to make it simple. So going here, density is 1, viscosity is 1, change and create, close it. Then we'll go to the boundary conditions, make sure that's a wall, pressure outlet's fine, symmetry, interior, and inlet is velocity inlet. go here and do the 0.7 meters per second. Once that's applied, you'll close it. Go to reference values, compute from inlet, and reference zone surface bodies. And for methods, keep it simple. Presto, then the rest is fine. And the monitors, residuals, go to the E-6, and just copy that down the board. Press OK. Right. And then now it is time to initialize. Go and press initialize and hope it doesn't crash. All right. Initialization is done. And then number of iterations. For the project itself, I did 1500. To save time, I'm just going to do 400 and calculate. And then we wait for this to run. There we go. Finally running. Hopefully it won't take too long. Only the 400 iterations. Okay. Calculation is complete. So then to view the forces acting on it, we'll print, and they're right there. And then you can put in an Excel sheet and get the drag coefficients, which are here. So if we go back to Fluent, and then we go to graphics, path line, and then for here we'll do velocity, select all, save and display. And this is going to show the velocity contours with the streamline patterns. go. We zoom in, and now you can see the contours. And then same thing but for pressure. Static's fine. Select all, save and display. Close, and these are your pressure ones. And I believe that's all you need for the exam. You don't really have to go into, or not the exam, for the project, you don't have to go into post. You can just get all the values you need here. Take these, use the coefficient equation to find the coefficients. Don't use the ANSYS ones. And then your path lines you can show here. And so if I want to go ahead and close out of Fluent, and this is for my next case, to just make my life easier, what I did is I just used the same geometry and same meshing for each case, and just changed the values to equal the correct Reynolds numbers. So okay, so I make a standalone system, then I drag the geometry. There we go. And now we just go into the setup. Let me name this one really quick. Next one is Reynolds number is 40, I believe. Yes. So now we'll go into setup for always double precision. Start. We'll let everything load in. Models, same thing, go to K epsilon. Or no, enhanced wall treatment. Okay. Materials. For this one, I also made everything one and change the velocity. So change create, close, boundary condition. And since everything's one except for velocity, and Reynolds number is 40, velocity is 40. And you apply and close. Reference values from inlet, surface body. Method, simple. Presto. Everything else looks fine. Modules, residuals. Okay. And then initialization. Go ahead and initialize it. cool, it's done. Back here, 400 duration, and calculate. Okay, so calculation complete. Again, reports, forces on the wall, print. So we get these forces, and then it takes a while, so I'm not going to do it again, but the path lines, if you want to do velocity, select all and then you press save and display for the path lines. About this Fluent. And then go here. This will be the Reynolds number between 100 and 200, which is the third case for that. I did 150. Same as before. Share the meshes, share the geometry. Precision. 5 this time. Okay. Maybe I won't do 5. All right. Same thing. Go back to the model. And wall treatment. Boundary conditions. For fluids, go to air. For this case, I kept the same density, and viscosity I changed to 0.1. Then change, create, and close. And for the inlet velocity, I did 12.2448. Just apply it and close. reference values, P from inlet, surface body, and then methods, simple, presto, residuals. It's just this same thing over and over again. Okay. And then go ahead to initialization, initialize. And now run calculations just to save more time. I'm just going to do 100 iterations. Again, for the actual project, I did 1,500 iterations, but just to get this video not to be an hour long. All right, and then same thing. Print, take forces. Let's go next now. Now you go to the fourth case, which is between 400 and 300,000. Same thing. I just shared them, set up full precision for started up. And for this case, I did 150,000 for my Reynolds number. K epsilon, enhanced wall treatment pressure gradient. And then materials, fluids, air. Density stays the same. Viscosity, I just made a little better or a little greater. Boundary conditions for this one. When finding the velocity at 150,000 with the parameters, I got 21.9097. Just apply, close, and then do the same thing over and over again. P from inlet, reference body, method, simple, presto, residuals, 1 to e minus 6. Okay. And then initialize and run. You've seen me do it 3 times before. I'm sure you believe that I've done it. Like, it's the same thing. Again, I used 1,500 iterations for my calculation when I was running it for my project. Just close this out. Okay, what's going on here? All right, so just name it. And then the final one is Reynolds number greater than 300,000. For that one, I did 400,000. Again, changed everything, or just kept everything the same, sorry. Shared everything. Solution for start. For viscosity and density of air, I'll actually keep the same for this one. So nothing to change there, just to make sure it's air. Boundary conditions, inlet. I use 5.8426. For velocity. And then and for the fun of it, I'll run this last one at like 100. And we can look at the pressure contour and make sure it's turbulent and everything. But go to run calculation, do 100, and then calculate. All right, and then get forces and path lines, pressure, save and display. Here you can see the pressure contours with the separation and everything. But yeah, that's project 3 with the 5 different cases for Reynolds number.